Dear student, now we will discuss about the real numbers of number line. Let's see.
We can use successive magnification to plot a terminating rational number on the number line. Let us consider the number 2.735 and try to plot it on the number line. Step 1. As the number 2.735 is greater than 2 and less than 3, it lies in the portion between 2 and 3 on the number line. Step 2. Now divide the portion between 2 and 3 into 10 equal parts and mark each point as shown. Step 3. 2.735 will lie between 2.7 and 2.8 because 2.735 is greater than 2.7 and less than 2.8. Step 4. Again, divide the portion between 2.7 and 2.8 into 10 equal parts. 2.735 will lie between 2.73 and 2.74 because 2.735 is greater than 2.73 and less than 2.74. Step 5. Divide the portion between 2.73 and 2.74 again into 10 equal parts. The fifth point after 2.73 is 2.5. Fill in the blanks with the correct values. We can also plot a non-terminating repeating decimal on the number line using successive magnification. Let us consider the number 12.6 bar and try to plot it up to the second decimal place on the number line. 12.6 bar expressed up to 2 decimal places is 12.66. Step 1. As the number 12.66 is greater than 12 and less than 13, it lies in the portion between 12 and 13. Step 2. Now divide the portion between 13 into 10 equal parts and mark each point as shown. Step 3. 12.66 will lie again into parts. The sixth point after 12.6 is 12.66. If we need to locate the number up to more decimal places, we can proceed in this manner. Fill in the blanks with the correct values. Fill in the blanks with the correct values.
Enter the two consecutive integers between whose the decimal number lies. First number, then second number. First number is 4 and second number is 5. Let's look at the portion between 4 and 5. From this portion, enter the two consecutive decimal numbers between whose the decimal number 4.52 bar lies. First is 4.5 and second number is 4.6. Step 3. Let's look at the portion between 4.5 and 4.6. From this portion, enter the two consecutive the decimal number 4.52 lies. Let's see, 4.52 and second number is 4.53. Step 4. Let's look at the portion between 4.52 and 4.53. From this portion, enter the two consecutive decimal numbers between whose the decimal number 4.52 bars lies. First number is shown 4.525 and second number is 4.526. Step 5. Let's look at the portion between 4.5 to 5 and 4.5 to 6. From this portion, enter the two consecutive decimal numbers between which the decimal number 4.52 lies. The first number is 4.5252 and second number 4.5253. Step 6. Let's look at the portion between 4.5 to 5.53. From this portion, enter the two consecutive decimal numbers between which the decimal number 4.52 lies. Then first number is 25 and second number is 4.52526. Now see the enter solution. Then step 2, then step 3, then step 4, then step 5. Then step 6,
Let's see how we can locate those irrational numbers on the number line that are square roots of natural numbers. Here is another method for drawing line segments whose lengths are equal to irrational roots of natural numbers. Notice how they form beautiful spiral patterns. We can also use this method to locate these numbers on the number line too.
first of all draw a line segment OA of unit length, then draw AB of unit length perpendicular to OA, then join the point OB to form a right angle triangle OAB. As per Pythagoras theorem, OB equal to OAB square whole root equal to root 2. Then you also draw the root 3 on a triangle. First of all, draw a line segment BC of unit length perpendicular to OB. Then join the points OC to form a right angle triangle OBC. As the Pythagoras theorem, OC equal to OB square plus BC 3. You also draw other triangles such as root over 4, root over 5, root over 6, root over 7, root over 8, then root over 9.
Let's look at a method root of a rational number x. To do this, we will make use of a right-angled triangle and the Pythagoras theorem. If the base of a right-angled triangle is x minus 1 by 2 and its hypotenuse is x plus 1 by 2, then using the Pythagoras theorem, we can see that its perpendicular is the square root of x. Let's now start construction to locate the square root of a positive rational number x. Step 1. Mark the 0 of the number line as point B. Mark point A on the number line to the left of B, such that AB is equal to x units. Step 2. Mark the 1 on the number line as point C. Note that BC is 1 unit, so AC is x plus 1 units. Find the midpoint AC by making perpendicular bisectors and mark it as point D. Now DC becomes x plus 1 by 2 and DB calculates to x by 2. We will construct a triangle EDB, where DB will be the base of the triangle and the hypotenuse DE to DC. Step 3. Draw a circle with its center at D and radius DC. Step 4. Perpendicular to DB, passing through point B and intersecting the circle at point E above. Now, we have a triangle in which the base is x minus 1 by 2 and the hypotenuse is x plus 1 by 2. As we learnt, in such cases, the perpendicular calculates to the square root of x. Thus, BE is equal to the square root of x. With B as the center and radius B, we can draw a curve in such a manner that it intersects the number line at the point F. Since BF is equal to BE, the point BF represents the square root of x on the number line. Tap the button to understand this better with an example. Let's represent square root 5.5 on the number line. Square root 4.26 on the number line. Let's summarize what we have learned in this topic.